This video is for anyone that is curious about how a two-stroke oil injection system works, or if you're like me and got a bike that you think is not running properly in terms of oil injection. You want to try and figure out what's going on and fix it yourself. First of all, a disclaimer: I'm not a mechanic, I'm not an expert, but I am a retired electrical engineer, so I understand electronics to some degree. So I plan on having 3 sections of this video. The first is just a general overview of how oil injection works. The second part will be some basic diagnostics you can do with just a multimeter. And then the third section will be some more advanced diagnostic techniques. So this is a Beta 200X Pro 2025. I've had it for about 5 months. It's got 45 hours on it, and it's never worked well. So I wanted to dig in and see what was going on. Let me start by explaining the symptoms I've had. Is what I have, which is an intermittent problem. I think the system basically works, but it's not working correctly. So the primary symptom was the spooge, excess oil coming out of the exhaust. After a few hours of riding on mostly single track, fairly slow, I'll have oil running all the way down, pooling up under here, dripping onto the swing arm and sometimes onto the brake rotor, and then my brakes don't work. So most people's oil injection works very good, very well, and they get very little spooge out of the exhaust, and that's what I'm hoping to get. The secondary symptom is the bike never ran very well. It ran good at idle, and it ran good at high RPM. Once I got the RPMs up to where the power valve was open, it ran pretty clean. It just sounded clean. But in between idle and higher RPM, especially right off of idle, it just ran really rough. It sounded like it was running rich. It just didn't sound right, didn't have the power it should. Finally found that if I increase the richness of the jetting a lot, way out of range for my altitude and temperature, I could get it to run fairly decent. But basically, we're dealing with a 12-volt system here. We've got a 12-volt battery and a charging system that charges the battery. That 12 volts goes to the computer, the ECU. It puts out a reference 5-volt signal to the throttle position sensor, which is down here. I have a smart carb installed now, but this has a throttle position sensor on there. On the stock carb, it's basically just a variable resistor or a potentiometer, and at idle it sends back a signal of like 0.8 volts, should be less than a volt, back to the ECU. A wide open throttle, it should be over 4 volts. The ECU monitors that voltage level to determine how much gas is being fed in, and then it determines how much oil you need, and so it sends pulses to the oil pump. I don't know if you can see it in there, but it's back in there. And it's easier to work on if you take the air filter out. Come over to the other side. The oil tank's up here. There's a line that feeds down, comes under here, and feeds into the intake to the motor right there. And if it's working well, then it's going to vary the pulse rate and just inject the right amount of oil. From what I understand, at idle, the oil mixture rate's about 200 to 1, And at wide open throttle, it's more like 30 to 1. I've currently disabled my oil injection, and I've got 60 to 1 premix. And with that, I get very little spooge. I do get some because my exhaust is full of oil. The pipe's got a lot of oil in it, and the silencer's just totally packed with oil. So I need to clean that out before I can really get rid of the spooge entirely. So that's kind of the basics. Okay, let's start by going over some documents I found. First of all, I've got the schematic, which was in the owner's manual. I've highlighted it, looking at or to trace the signals of interest. I also have an oil injection flow test I found online, and I can't remember what this document's called, but it's an older document, like 2018 or something, that has some tips on how to test your oil injection from like a cross trainer or older RRs. So I found these useful. Basic test equipment. You need a multimeter and some little jumper cables are handy. If you want to test your oil injection, I would suggest you start by doing the flow rate test. There are 3 possible outcomes. One is it's not pumping oil at all, in which case, if you're not running premix, your motor's probably seized. The second case is it's pumping oil at the maximum rate that it would do at wide open throttle, which is something like 30 to 1 mixture, which will generate a lot of spooge. The third option or case is it's intermittent, which is the case I had. If you've got the first case that's not working at all, this video should help you test all the components, but you'll need to run premix to do any testing. The second case, where it's pegged at full oil rate, I would suspect something wrong with your throttle position sensor. Because if the ECU detects something wrong with the TPS voltage, it'll default to maximum flow rate to protect the motor. If it's intermittent, I would suspect the wiring system. You've probably got a poor connection somewhere, which I believe is the most common cause of failures with oil injection, at least on the betas. They have a history of having bad connectors. I think they've improved them compared to older models, but that's still the first place I would look. The oil injection flow test. Here are the instructions, and 3C's Recreation has a video on how to do this. It's kind of a pain. You need a syringe with a needle. It says basically at our idle RPM of 1700, it should take 45 seconds for the oil to move 2 inches. And their test procedure is pretty complicated. I found an easier method is just carefully unplug this hose from the intake port there. Stick your syringe in as far as it'll reach and inject in a small air bubble. And then start the bike and see how long it takes the air bubble to move 2 inches. And if your syringe isn't long enough, it's 45 seconds for 2 inches, so it's about 22 seconds for 1 inch. And you should just see it move. It'll pulse about every 2 seconds. It'll take about 22 seconds for it to move 1 inch. Then you can inject another bubble, do it again, but this time rev it up, and the pulse rate should be faster. And you should see the bubble move a lot quicker. To test the TPS, you really need to take the tank off. The connector from TPS to the ECU is under here, so you need to take the tank off to get at it. But since I have a spare carburetor right here, I'll demonstrate how to test it. So this document says that between the blue and black I should have 4.6 k ohms. I've got 5.2. I think that's fine. All this is a voltage divider to take the 5-volt reference and divide it based on throttle position. So if I move from the blue to the yellow, now it says it should be 600 ohms at idle and 3.2 k ohms at wide open throttle. So I'm 757, and if I open up the throttle, it increases. So without it hooked up to the throttle cable, I don't know what the actual limit is, but it looks like the TPS is working. This is a fairly simple thing to test. And then plug it back in when you're done. The next test is the oil pump. So it's easier if you take your air filter out and unplug the connector and measure the resistance of the oil pump. It should be about 18 ohms. And I measured mine and it looked good. This is the ECU right here. This is the oil pump connector that's currently disconnected. This is your test port for an OBD2 scanner, which I'll get to later. So the oil pump's pretty easy to check. Okay, the brain of the whole system is the ECU, and if that's got problems, who knows what's going to happen. That's an expensive part. I think it's about $350. So you don't want to just buy one and swap it and hope it works. If you have an OBD2 scanner, you can plug that in with the adapter cable that came with the bike. At least if it's a beta. This procedure should work for any brand to some degree, but the specifics will probably vary. So the other key on the ECU is if you've been getting check engine warnings on the dash, then certainly start there. Figure out what's going on causing the air conditions. When you first start the bike, the check engine light will come on while it wakes up, but then it should go off. The check engine light here, and it says check, and then that all goes off. If the check engine light stays on, it could be because the ECU's recorded a TPS fault. And if it does, it will cause the oil injection to default to the max rate. So you'll have a lot of smoke and be burning a lot of oil, probably get a lot of spooge. To reset that, you can start the bike and kill the bike 3 times in a row, and it should reset the ECU. Next test is the power system. So there are basically 2 stages to the power. There's the battery, which ought to be 12 to 13.5 volts, and then there's the recharging system. So you can see here I've got 13.3 volts, so that's good. When I start the bike, if the battery was lower, for sure you'd see that value go up as it's being recharged. With it this high, I may not see that. Okay, I have my voltmeter set on DC volts. Positive hooked to the positive terminal, negative hooked to ground. When I rev the motor, the voltage goes up a little bit, so that says the charging system's basically working. If I now put it on AC volts, Okay, the last component for the basic test is the wiring harness. My guess is maybe 80% of failures, if you have a failure like mine where the oil injection basically works but it's just not tuned right, it's probably a wiring problem. When inspecting electrical connections, most people think about the pin to pin, the male to female connection. So they may put dielectric grease on to help prevent corrosion on that. But there are two other connections as well. It's where the wire attaches to the connector pins. Quite often they're just crimped, and those might not be crimped properly. If you tug on the wire, it may wiggle, or it might even just pull out. I've had that happen multiple times. When I made my little test jig here, I soldered it on just to make sure I had a good solid connection. So when you're checking your connectors, think about the wires as well as the connector itself. As far as I'm aware, there are two common failures with connectors. One is just an poor electrical conductivity, and the other is corrosion from weather or water. If you live in a wet environment, humid, or a lot of rain, or you're doing a lot of stream crossings, weatherproofing your connectors may be worthwhile. If you're in a dry environment like I am, I think connectivity is the more important issue. I've personally never seen a failure due to corrosion. If you have a connector like this, it's waterproof, so you really don't need to do anything except maybe put some contact enhancer on the pins, and it should keep the moisture out without trouble. But a lot of connectors are more like this. They're open. They could easily get water in them. So what I'd recommend is putting a contact enhancer on the pins and giving a tug on the wires to make sure the crimp is tight. If it isn't, then you need to extract the pin. Some pins are pretty easy to extract, others are a real pain. But extract the pin and crimp it tighter. A lot of people recommend pulling open all the connectors and putting dielectric grease on them. I've seen videos of people just put gobs of dielectric grease. I think that's a really bad idea. Dielectric grease is an insulator. It will protect from water corrosion, but it can also interfere with your electrical connections. The current coming out of the ECU to drive the oil pump, I think it's on the order of 0.7 amps. That's a lot of current. And if you have resistance on those pins, you're going to burn out those pins. So if you do want to use dielectric grease, use it very sparingly, just a small amount, and mostly put it around the outside of the connector and not so much on the pins. What I've done, I use Stabilant 22A. This is a contact enhancer. So you pull open the connector, use a small brush, and brush some of these on both connectors, the male and the female. Let it dry and then plug it back together. And when current flows through this dried liquid, it will enhance the connectivity and give you better connection.